Okay, that'll be handy. All right. So this is 1 over R1. So these two can be treated parallel, right? So it's going to be 1 over, nope, it's not going to work either today. 1 over RT equals 1 over 20 plus 1 over 30. Agreed? So I'm going to go 1 over RT equals, now we're not going to just Hammy did it because he's crazy and likes math apparently. We're just going to put it in the calculator equals. If I can find a calculator, will do that for me. Here's 1. So we do 1 divided by 20, whoops, 1 divided by 20, plus 1 divided by 30, which should be good. And then 1 divided by the answer, agreed? And I get that this is a what ohm resistor? What does this count as? Did you do it? You didn't do it? Well, tell you what you get, and I'll tell you if you did it right. 1/12, so therefore 1 over RT equals 1/12, so what does RT equal to? 12. Okay, so this is like one big 12 ohm resistor, agreed? Okay, now that means that these two together, this one here and this one here, would have total resistance of what? These are in series, right? So an electron that has to go through this and then through this mess would run into how much resistance total? 22 ohms. So the total resistance of this circuit is 22 ohms. Agreed? All right. That's where we're going to start combination problems. We're going to find the total resistance. Next, how do I find the total current? I think you said it right, but I've got a wagon going in the hallway, so if I say it wrong. V equals IR. So 100 equals I times 22. Is that agreed? And then what do I get when I do that? I equals, I got 4.545-ish amps. With me so far? Okay. So that is my total current coming out of the battery. Agreed? So I know right now, boom, 4.545 amps coming that way. All right, switching people. Slowly. All right. Now it says what's going through each of the resistors. Well, how much current's going through this resistor right here? How much current's going through that one right there? Yeah, because whatever's coming out of the battery has to go through that resistor, doesn't it? So there has to be 4.545 amps going through that one. So through resistor 1, there has to be 4.54 amps. All right. Next up, how much is going through this one? Can't be because some's going to go this way, isn't it? So it's going to split. Now I go, oh, and I like exactly what you did there where you grab this with, oh, now what? All right, there's a procedure for getting through this mess. Here's the procedure. Hope you two are paying attention to their giggles. 4.545 amps through a 10 ohm resistor. How much voltage does that take? 45 point something, right? Because I would use what, Miss Solely, to find voltage? V equals IR. So the V equals IR, I'm going to get voltage is equal to I, which is 4.545 times 10. I get 45.45 volts. Agree?
That's what the voltmeter reads?
That's what the voltmeter would read, but I haven't even talked about that. That's how much voltage I lose going across here. Wait.
So that's what the voltmeter reads, right?
Yes, but I haven't talked about that yet. Want me to repeat that one more time? Yes, but I haven't talked about that yet. That's not the point. The point is this. The point is, how much voltage does it change from here to here? How much voltage does it change? I'm using 4.545 amps through a 10 ohm resistor, so 45 volts must be being used getting across here. Is that okay? I said nothing about, I don't want to talk about the voltmeter yet. Okay? If I've used that much voltage getting across there, how much am I going to use